FeatureCAM to Vericut automatically exports your stock, part, tooling, clamping and NC code information into Vericut format, creating a project file that can be simulated by Vericut. A significant number of changes have been made to the FeatureCAM to Vericut interface. This demonstration highlights the new workflow. So the first thing I'm going to do is ensure that I have my Vericut verification license enabled. I'm just going to close my project file, come to my evaluation options, and if I look, I can see that I have Vericut verification license is activated. So this is a requirement for the FeatureCAM to Vericut interface. I'm then going to load in my relevant project file. If we look towards the part view, we can see we have numerous pre-programmed features. Within the stock tab we have our part design. We also have a list of clamps. So the first thing I'm going to do is come to my machining attributes, and I'm going to ensure I've left a suitable allowance, in this case of 1 mm, when avoiding the fixture and clamped regions. If I play a 3D simulation, we can see the finished part like so. And we're now ready to export this part into Vericut. Now just before we do so, we must create a reference location for the correct positioning of the part on a table within Vericut. So Vericut uses attach components to define these locations. In this instance I've created a UCS called attach at the bottom of my stock like so, centered at the bottom face. I can now go ahead and load in my add-in. So I'm going to go to the add-ins page and switch on FeatureCAM to Vericut. Say OK. I see my Vericut icon on the utilities toolbar, and I can simply run this like so. So what we see is a new layout to the user interface. Straight away I can select the output directory that I wish and select my TSPM folder. Additionally, we're required to provide a Vericut template. Again, I can go into the library, and in this instance I'm going to choose a 3-axis mill template metric. Say OK. So it's also important to note that prior to the export I'd loaded in a relevant post processor, so I'm matching the Vericut template to the post that I've used. With regard to the setups, if we had multiple setups, these would be listed here, and I could provide relevant templates for each setup. So we can choose to export both the NC program and tools. If you decide not to, Vericut will use the default configuration within the template, of course unless otherwise specified by the user. We can now work our way down the user interface. So the first thing I'm going to do is come to my tools options. Here we can clearly see we have 3 settings for the tool. Now it's recommended that you select the method that's used within your post file. So if your post file organizes and names your tools via tool numbers, then you should use that method. If it does it by tool IDs, then you should use tool IDs. So I'm going to accept my tool numbers, so the positions in the crib, and next I want to establish the user coordinate systems. So the first user coordinate system that I need to specify is an attach point. So as I mentioned before, I created a UCS labeled attach, which was located at the bottom center face of my stock. And the component to attach to within Vericut is going to also be attach. So the user is required to know the names of the various attached components within Vericut for successful export. I'm then going to move on to my stock and design. As I've run through this demonstration before, these are already filled out. You should always wish to export the stock solid, and In this case, the attached component I'm going to choose as stock. And of course, the reason we wish to export a stock solid is so that Vericut has something to cut. With regard to the design, my solid name is bracket, so I can select bracket, and the attached component within Vericut is going to be design. So I can say OK to both of those. In terms of fixtures, it's likely that when we first initiate our fixture dialog that these attached to values are going to be blank. So as we can see, we can update each individual solid by selecting the relevant attached component, but in this case we have numerous solids within our project, so we wish to do a local update of all of these, and we can do so by simply selecting all of the clamps within our project. Coming back to our fixture export page, and we can then choose to select solids in the project. These all become selected, and we can do a mass update by selecting the relevant attached component. So in this case, of course, we want fixture, so I can say OK. And finally, I need to establish my work offset. I'm going to delete the offset that's already within there. My offset name, unless you're using a 5-axis program, typically you would choose the work offset. In my register, I have the 54 option, and this has come from the fixture ID within my setup. Subsystem, there's only one subsystem within this particular template and machine, so I can have that selected. The from component in this case is going to be the spindle, and my to CSYS origin is going to be my user coordinate setup 1. So once we've filled out these parameters, we can add the new offset like so and press OK. So at this stage I have already specified the location of my Vericut batch file, and this is so that we can use the export and open option to do both an export of all of the information we've provided and additionally open our project within Vericut. And if the user wants, they can also simply export the files and use them later within Vericut. So I'm going to select my export and open option. It's going to run through a simulation, a centerline simulation of all of the toolpaths. I get a pop-up message to say that's done, and what we can now see is that we have our Vericut project opened within Vericut. So I'm just going to navigate to the location of that particular project so we can see the files that have been output. So within my TSPM folder we have a clamps folder which contains STLs of all the clamps used. We have a holders folder which contains STLs of all of the tool holders. Looking at the bottom of the list, we have our stock block and our part design. Working our way up, we have the Vericut project itself, tooling information and NC program information. So if we look towards the project tree, what we can see is that we've loaded in our relevant machine. If we show our fixture models, we can see all of the clamps located like so. We can also see our part design file. So if I come and set my component visibility, switch off the stock and show the design, we can see our design like so. I'm just going to switch that back to the stock. We have our relevant coordinate systems transferred across. There we have our attached component as a reference to the table location. With respect to the tooling, we can open the tool manager and see information regarding all of the tools used within our FeatureCAM project. and we have the NC program that's been generated within FeatureCAM like so. So at this stage we are ready to simulate. Just going to zoom in here. Can run the simulation. And in this instance we see our finished part like so.